I want to show you one final example as we're going through calculating these derivatives using algebra. And this one is going to be hard enough that one of the two techniques isn't going to pan out for us. And so we'll see why that is and what we can do with using the other technique. All right, so this time we've got f of x is equal to x cubed, and we want to calculate this derivative at 2. All right, so let's see what the first definition gets us to. So f prime of 2 is equal to the limit as x approaches 2 of f of x minus f of 2 over x minus 2. So this is the limit as x approaches 2 of f of x is x cubed. F of 2 is 2 cubed, which is 8. So this is x cubed minus 8 over x minus 2. So this is a factoring problem that you may not know how to solve. I will eventually give you a cheat sheet that gives you a little bit of factoring techniques that would give you some idea about how to factor x cubed minus 8. But I don't want to do that because I don't want you memorizing factoring techniques all day long. What I want you to do when you hit techniques like this is the kind of reason why this second definition works out better for us. So let's just kind of let that one slide, and we will look at the second definition. This is the limit as h approaches 0 of f of h plus 2 minus f of 2 over h. All right, so this time, this is the limit as h approaches 0. We just substitute h plus 2 in for x in our definition. So this is h plus 2 cubed minus f of 2, which is 2 cubed, which is 8, over h. All right, so the tricky part here is that we need to calculate what is h plus 2 cubed. All right, so h plus 2 squared is h squared plus 2h plus 4. I'm sorry, h squared plus 4h plus 4. And so we need to multiply that times h plus 2. Let me go back one step. This is just h plus 2 cubed is 3 copies of h plus 2 multiplied by each other. And these two become h squared plus 4h plus 4. And so we need to multiply that out. So what I'm going to do here is I'm going to use kind of the FOIL technique, except with my fingers. So the first term, h squared times h, is h cubed. H squared times 2 is 2h squared. And then 4h times h is 4h squared. 4h times 2 is 8h. 4 times h is 4h. And 4 times 2 is 8. So notice that I multiplied each one of these 3 terms by each one of these 2 terms. And using a FOIL-ish kind of technique, I just made sure that I counted each one of them. I didn't double count any of them. I didn't miss any. So now we can combine our like terms. So that's h cubed plus 2h squared plus 4h squared is 6h squared. 8h plus 4h is 12h plus 8. So that is what h plus 2 cubed is equal to. So let's substitute that into our problem over here. H cubed plus 6h squared plus 12h plus 8 minus 8 over h. And this is one of the things that I mentioned in the last video, is that it looks like a ton of arithmetic and algebra to do, but it works out for us. So the first thing is we notice that this plus 8 and minus 8 cancel out. If you try solving a problem like this and find that that doesn't happen, double check your work over here because something has gone wrong. It really should cancel out. So that's h cubed plus 6h squared plus 12h over h. And now that the plus 8 and minus 8 has canceled out, I've got a whole bunch of terms that each contain a factor of h. So I can factor out the h if I want to. All right. In the last problem, in the last video, when I did this, I did an extra step where I factored the h out of all of this, but you don't have to. So h cubed divided by h would be h squared divided by h would just be h, and we cancel out that h. So that gives us the limit as h approaches 0 of h squared plus 6h plus 12. And now we've got an example where we just need to substitute 0 in for h. And you find when you do this that all of the more complicated terms cancel out, and you just get 12 as your answer. So even though this is kind of a mountain of algebra, you didn't need to know any factoring terms like you would need to know if you did this technique over here. And basically every step you're doing is just kind of double checking that the evaluation you did over here worked out. So at any rate, we came up with an answer of 12 for the derivative of x cubed when our input value was equal to 2. All right, so that's the most difficult kind of problem you're going to see when we are going to be doing our algebra practices with calculating these derivatives. Well, we might see more complicated examples a little bit further down the road. But this gives you the idea of how you're substituting things in and using these values in order to solve problems. So give yourself a good clean sheet of paper and see how you get from this. And as you're doing this mountain of problems, see if you can start to identify an intuition about what you think the answer is going to be. Because what we're going to see fairly soon on is that there are rules for coming up with these derivatives so that we can kind of avoid this work if we want to, and we probably do. It's a lot of work, but if we keep up with this practice, we will find a simpler explanation down the road.